So let's say that you have an aortic aneurysm and that it ruptures. So unfortunately, you only have about a 10 to 20% chance of surviving this medical event. But what is an aortic aneurysm? So your aorta is the leading artery coming off of your heart, and this is delivering blood to the rest of your body. And an aneurysm is a bulging vessel. So an aortic aneurysm is when you have a bulge in your aorta. And because the vessel walls are weaker at the aneurysm site, this aneurysm then has a propensity to burst, which is usually fatal. The traditional method of tracking aneurysm growth is to use repeated CT scans where they measure the aneurysm size. And then once the aneurysm reaches a critical size, surgical intervention is discussed. However, this method presents a major problem in that it can take years for the aneurysm to reach this critical size. And this leads to many expensive CT scans, as the cost of a CT scan can range from $500 to $5,000. And additionally, many medical centers don't even have a CT scanner. And this creates a problem for patients in that CT scans will have long wait times and are geographically inaccessible. And finally, this traditional method also in CT scans is also an issue because the contrast agent is actually toxic. And so by receiving many CT scans, the patient can later develop other adverse health effects. So the goal of my thesis is to develop a method for tracking aneurysm growth that reduces the number of CT scans required. My proposed approach is to use one initial CT scan to determine the aorta geometry and aneurysm location, and then to take pulse measurements at various locations on the patient. These pulse measurements and aorta geometry are then fed into a computational model that establishes a baseline model for the patient. Then, in subsequent clinic visits, the patient has these pulse measurements taken again and fed back into the model. The model then predicts if the patient's condition has changed or not. If the patient's condition has changed, then the patient is sent to receive a CT scan to track the true aneurysm growth. Otherwise, the patient can wait another round for more pulse measurements. This method drastically reduces the number of CT scans required, which not only reduces healthcare costs, but also provides a more accessible method to track aneurysm growth, as these pulse measurements can potentially be done even at home. So overall, this method will provide cheaper healthcare as well as a more accessible method that will reduce the risk of a fatal aneurysm rupture. Thank you.